According to the NHTSA, 9 people in the US are killed every day in crashes reported to involve a distracted driver. The mobile devices and services that we use every day are becoming increasingly integrated into the vehicle's main display. Ensuring safety means eyes on the road and ensuring we distract the driver for the least amount of time possible, while still providing access to navigation, media, communication and comfort features. If we could predict what feature or what setting the driver needed at a particular time while driving, we could proactively present a shortcut to this item on the main screen, reducing the time they spend operating the screen with eyes off the road, and ensuring we offer the highest levels of safety. With access to a large number of internet-connected devices, vehicles, and regular driving, we have access to a large amount of data that we can use for predictions. We also have a diverse group of users we want to personalize our solution for, and the vehicles operate in diverse environments, so coming up with a rules-based model may not be suitable. The target user for our solution is the driver of the vehicle. They often need to access a feature or change a setting somewhere in the infotainment system for climate control, navigation, music, and so on. While they're doing this, they're not paying full attention to the road, increasing their stress and reducing safety for all road users. Today, they have to remember where that particular feature or setting is and how to navigate there through the menus. Even if they do remember, they still have to spend the time navigating there. With our solution, we expect to be able to reduce the time the driver spends being distracted by the infotainment system. For our outcome, we will measure the amount of time the driver spends navigating through the menu structure of the infotainment system. Our model's output will be the top likely actions on the infotainment system the driver is expected to take at any moment in time. In other words, what they need right now. We will judge the model's success by how often one of those top predicted actions is chosen by the driver compared to navigating through the menu system instead. We can consider the following factors for the model. In terms of people, we've got the driver identity and how many other people are in the car. Related to time, we have the current time of day, the current day of the week, whether it is a working day or a weekend. And related to the vehicle, the current infotainment screen or app being shown, the current media source playing in the background, whether CarPlay or Android Auto is connected, the seat position forwards and backwards, or the seat position up and down. In terms of climate, we might have outside temperature, how much it is raining, the cabin temperature, or the cabin humidity. So the solution concept is to develop a machine learning model running on the infotainment system that learns the driver's behavior and predicts what feature or setting they want at any moment in time. The model will adapt over time. We also train a cloud model on subsets of this user population to gain the wisdom of the fleet. We can start with a focus group of drivers and interview them about and observe them using the infotainment system to validate the likely set of important features we should use for our ML model. We can gather some initial training data from our employees using the infotainment system on company vehicles before we have real customers using it. We will see how well our predictions hold up. When the model is first rolled out to drivers, we don't know anything about them to generate meaningful predictions. And in the vehicle, we don't want to ask them to wait several minutes to input lots of information. So we can use a heuristic-based model at the start to ensure we have some predictions to show in the new panel and start to get feedback from it, as well as drivers navigating through the menus, and thereby training the model. With drivers opted in to such data collection, we can also use this large data set in the cloud to train a whole fleet ML model, which will mean we can roll out better performing starter models to new users, which then learn their particular behavior. So we will train and use the personalized model on the edge, on the vehicle, since connectivity may not be available. We could be driving through tunnels or remote countryside. But we will train a whole fleet model in the cloud to gain the wisdom of the fleet. The in-car model will be learning online. As the driver takes actions, including using our predictions, we will train the model. The whole fleet model will be trained offline once data is uploaded from the vehicles, and new models can be rolled out to new users or even used alongside the car's existing model, merging the results of the two. Predictions are likely to be a mix of time sensitive, like changing weather, number of passengers, and less time sensitive, such as favourite radio stations or seat positions. So we can use both batch and online prediction. We are initially going to train based on heuristics and then limited historical data, and therefore we may encounter a training or serving skew, a difference in the training and production input data. Over time, we should expect data and concept drift as vehicles change, behaviour changes due to a pandemic, new media sources becoming available and becoming popular. Okay, thank you very much. My name's Dan Haley.